Everyone, welcome to my YouTube channel JavaByMK. So today I'm going to continue with my Kubernetes series. So in this video I'm going to explain Kubernetes architecture. In my previous video I have given an overview of our Kubernetes and a brief introduction of why it is required like this. So in this video we are going to continue with the Kubernetes architecture. So as you can see on the screen we have components listed that we have in Kubernetes. So as I explained in the previous section, we have control plane, or we call it as control panel, which is basically a brain of Kubernetes, and API server, scheduler, controller manager, and etcd are components of this control plane. Okay, and any request which comes to Kubernetes, it could be either UI, or we have kubectl is basically a command that we provide to perform operations on Kubernetes. So in the later section we will understand how kubectl works. So one by one we are going to understand each components, what API server is, what scheduler, what controller manager, and what etcd is. Okay, so I for a better understanding I am going to give a analogy. Okay, so we as I have told in previous video, we are going to provide a live demo of e-commerce web application deployment. Okay, so with that in mind, we will have like all the components, we will provide a analogy for, so that it becomes easy and very basic for everyone to understand. So a cluster is basically the Kubernetes app. Okay, API server is basically e-commerce app. Okay, so the users is going to interact with Kubernetes, and that will be from the application e-commerce app. Etcd will be web portal. Scheduler will be database, like orders, users. Controller manager will be service managers. So this might be confusing for a lot of users, so I'm going to go ahead with one by one what each components means. Okay, so the first one is API server and how Kubernetes API server works. Okay, so as I explained, like API server is the starting point of any request. So when any request comes to Kubernetes, it first comes to API server. Okay, and so what I mean to say, suppose this is I'm going to explain this. Suppose going to we have a customer deployment YML. Okay, and we are going to create the pod based on what is written in this YML. I will also explain this right now. Okay, so let me go ahead now itself, so you can see one side. I will directly go to the YML. Okay, so here you can see this is the YML. Okay, and what we have in YML is API version, kind, specification, and how many replicas we need. Okay, and label, we give label here, what we call it as. So this is the distinguish between all different services we have. Then we have container, customer, and we also have container port. So these details we have. Okay, so once we run this command. Okay, we have command also, so we run this command to apply this YML. Okay, so once we run this YML, we what API server does, it authenticates the user. It provides authorization also. Along with this, it validates the YML whether the YML format is correct or not. And this API server also store the details of the YML into the etcd. Etcd is basically the database of Kubernetes. Okay, so if we take a key takeaway is the brain's front door. As I explained, uh, control plane is the brain of the for Kubernetes, and API server is the front door. Okay, now the next step is Kubernetes node. So node, I will not give much time to the node, as I explained here that we have worker node like this and this. Okay, so what this node is basically, so node is basically the machine that actually runs your e-commerce application. Okay, so node is basically uh, is registered itself with API server. Okay, and scheduler assigns pods to the node. I will explain what scheduler is and what kubelet is, what kube-proxy is, one by one. So basically on a higher level, if I can say, then I can say like node is basically the machine where the we run where the Kubernetes runs. Okay, and okay, and it, and one Kubernetes can have multiple machines, multiple nodes. Okay, so now the most important part is so scheduler. Okay, so as I told you that his scheduler is part of the uh, Kubernetes architecture. So what Kubernetes does in respect to e-commerce service? Okay, so um, so basically, uh, when we create a pod, like when we run the deployment YML, then based on that, pods are created, but those pods are created in pending state. Okay, so so scheduler, what scheduler does, like when pods are created, they are created in pending state, so that means no node is assigned to that particular pod. Okay, so as I mentioned, that node is the machine. Okay, so any pod that will be created needs to be assigned to that machine, that node. Okay, so scheduler does that work. It's suppose we have three nodes. Okay, and we just created pod p1. Okay, so scheduler decides the newly created pod goes to which node, which machine. So for that, scheduler checks CPU, memory, and node availability of all the available nodes, and based on those, the availability and the CPU memory size, it creates a score of all the nodes, and the node which is having the highest score, that particular node's newly created pod gets assigned to that particular node. Okay, okay, so then basically scheduler decides a newly created pod will go to which node. Okay, so next one is Kubernetes controller. So as I explained, that the controller is also a part of Kubernetes architecture. So and scheduler's work, I have already explained that it is responsible to assigning newly created pod to respective nodes. Okay, what pod is, I have, as I explained in my previous video, pod is basically where the application runs. So pod is equivalent to application. Okay, and if I come to this controller, so it's basically suppose we provide in the uh, pod creation YML that it there should be two replicas always. Okay, so basically controller checks like what is desired and what is actual. Suppose desire is two pods, and suppose in the running, only one pod is in the running state and one got crashed, so there is a mismatch. So then what the controller does, it gives the instruction, to the kubelet that we are sort of one pod. Then kubelet from there takes forward, like kubelet is a part of the worker nodes. So from the controller, the instruction goes to the kubelet, and kubelet's work is to create the one pod. Okay, so basically this is what controller does. It is basically it is a kind of manager. It checks regularly for all the services, customer service, product service, all the services that we have, whether the pods are in the running state and desired and actual should be equivalent. Okay, or if there is an extra pods created also, that then controller deletes those pods also. Okay, so next one is kubenet. Okay, so basically okay, so basically uh, kubenet is basically as I explained, like it is a part of worker node. So it is where the application cube and worker node is basically where the application runs. So kubenet so we, as I mentioned, like from the instruction that we give in form of yml, a pod gets created. Okay, so kubelet responsibility would be to assign ip to all the pods. Okay, so pods should have a unique ip address. So kubelet responsibility is to assign unique ip address to every pod. And if there is the if any kubelet, if the pods wants to communicate between them, then kubelet does that work. Okay, so uh, basically kubelet is responsible to create the uh, basically it provides communication between the pods and also to create ip for all pods. Okay, now we have kubectl. So as I explained in the diagram previously, that kubectl is basically command that kubectl and kubernetes are two different parts. Kubectl is basically the command, cli command that through which we communicate with kubernetes. Okay, so example, this is one example. Okay, so this example cubes this is if we run this command in uh, command terminal, then it will apply this customer deployment yml to kubernetes, and then uh, this instruction will go to the kubernetes and all the required instructions will be implemented. Okay, so as I explained, that Kubernetes kubectl sends the request to Kubernetes API server, and from the API server, uh, based on just like other we have controller, scheduler, all does all the work, and from there it goes to the worker node, and kubelet assigns the IP address to the pods and to all the pods, and all this work is being implemented. Okay, so as I said, like API server validates the request, controller notice the change. Okay, and what is the desired state and what, and scheduler assigns pod to nodes, and kubelet runs the container, like pulls docker image, starts consumer, product, seller, all the things. Okay, so now next one is service. Okay, so now like as I already explained uh, all the all the components of all the components of uh, Kubernetes architecture, but service is not a component, it is an abstraction. Okay, so as like all the pods will have a unique IP address. Okay, and as explained, that pods might delete, might get added. So the IP address of the pod is uh, is if any user wants to access any particular service, so all the any particular service can have multiple pods, and all the pods will have a different IP addresses. So to access any of the service, we have any of the customer, product, service, we will have a cluster IP. So a unique IP address will be assigned to each one of the services, like customer service will have a unique IP address, product service will have a unique IP cluster IP, like all this. Okay, so So we, as I explained, like pod IPs are not reliable, but service is basically provides a stable IP address, and that IP address can be used for that particular service in the sense like microservice. Okay, so how it gets, how service creates the cluster IP. So basically it uses kube-proxy. Kube-proxy I will and like is a part, is one of the component in worker node. Okay, and it is responsible for the all the networking part, like all the networking within worker node is being taken care by kube-proxy. Okay, but outside node and outside pod we have a service, and each and so stable IP for the service. Okay, so client will, if any user will connect with service, that is cluster IP, and from the cluster IP the request goes to which, like whether pod 1 or pod 2, based on the requirement. Like and there are different techniques through which IP address is assigned to service. Okay, now next is okay, so in the next video we are going to understand how ingress works in Kubernetes. So till now I have already explained a lot of things. So I have tried to explain as basic as possible. If you will listen to the video, it will make a lot of sense. Okay, so thank you for watching.